Hi, my name is Rachel, and I'm a PhD student at Vanderbilt Center for Rehabilitation Engineering and Assistive Technology, or CREATE for short. I'm going to be talking about wearable robotic devices in this video, which are a specific category of robots we work on in CREATE. In the field of assistive technology, the majority of robots we design are wearable robotics, meaning they are powered devices that attach to a person's body. In some cases, wearable robotics are designed to replace a missing body part, such as an arm or leg. These are typically called prosthetic devices. Exoskeletons, on the other hand, are wearable robots that are designed to improve the function of an existing body part that might be impaired by working alongside it. To build these wearable robotic devices, we combine our knowledge of biomechanics by studying how the human body moves with our programming and design skills. Using biomechanics, we can understand how a person's body moves when they are healthy and also how it moves when they have a disability. For example, after someone has a stroke, they might have trouble walking, and through studying their biomechanics, we may find out this is because they have less ability to move their hip and knee joints. We can then use this understanding from biomechanics to design robotic devices to improve the function of the missing or impaired limb. We design and build the mechanical part of the device to fit on a person's body and include all the necessary components like motors and springs. Then we design a way to control the device using programming and electronics to make the device act like the part of the body it is assisting. To help someone move their hip and knee joints, we could build a robotic device that fits on their legs with motors at the hip and knee. We can then program the motors to help bend and extend these joints at the appropriate times during walking. After we have built the device, we need to test it to evaluate if it works. We return to studying the person's biomechanics to do this. We often evaluate how a person moves with and without the device to see if the robot we built is helping in the way we intended. After evaluating the device, we often decide to make updates and changes to our robot. These may be because our design didn't work, or even if it did, we often make changes to try to improve our robot. Here is a diagram of a robotic prosthetic leg that is designed to act like the missing knee and ankle joint of an individual who has lost their leg. You can see some of the mechanical components between the first and second generation changed, such as the design of the ankle joint and the foot. The embedded system is where the electronics and programmed controls are located on this device. Because the mechanical components of the robotic leg changed, these electronics and controls also have to be updated to work correctly with any new sensors or motors. There are several common challenges that are often the reason we need to redesign robots. First, we often are trying to improve the function of the device and its ability to help the person wearing it. Wearable robotic devices need to be programmed so that they are able to adapt to the variable ways a person moves. This is a unique challenge in wearable robotics because other general robots that are not connected to a human can be programmed to act the same way every time they do a task. But we need to program a wearable robot to do its task in a variety of situations. For example, a wearable robot cannot be programmed to only work at one speed of walking because the person wearing it may need to walk slowly sometimes and very fast at other times, like if you're late for class. Also, we want to program wearable robotics to allow the user to retain agency. This means we want them to feel like they are in control of the device they are wearing and that the device is not forcing them to move in certain ways that may be uncomfortable. We also face design challenges when building our wearable robots. We often want the battery providing power to the robot to last as long as possible, and we want the device to be as light as possible. These are common design goals for any type of robot, but are especially important for wearable devices. If a robot is helping someone walk, we need the battery to last them all day so they can do things like go to work and hang out with friends before needing to recharge their device. Also, the device cannot be too heavy because it is attached to someone's body and it would be very exhausting to move around all day with a heavy device attached to you. Additionally, we always want to decrease the cost of the device so more people are able to buy a robotic device to help improve their mobility. Overall, robots are used in a variety of settings in our world and for a variety of purposes. Combining our knowledge of biomechanics and robotics allows us to design and build wearable robotic devices to improve people's ability to move and their lives overall.